All right, in the next question, we are supposed to use the first two non-zero terms of the Maclaurin series of this function sine x divided by 4 plus x squared to estimate its integral from 0 to 0.2. So how do we do that? So to find the Maclaurin series of this function, basically there are two ways. So one is to just find consecutive derivatives of this function and evaluate them at 0. The second way is to take the Maclaurin series for sine x and multiply by the Maclaurin series of 1 over 4 plus x squared. Okay, and if you want to use the first way, it is doable, I guess, but it's just that you will have to differentiate this function 3 times, which is not probably very easy. So I think it is easier to use the Maclaurin series for sine x and the Maclaurin series for 4 over x squared, right? So let me explain what I mean. So what is sine x, right? So sine x, you can, well, notice that we are interested in the first two non-zero terms, right? So basically, sine x is going to be x minus x cubed over 6. Well, plus, well, let me write in the next one with different colors. So plus, there's going to be x5 over 120, plus that there's going to be some higher order terms. But then we are only interested in the first two non-zero terms of the product, right? So which means that, you know, if we have x to the 5 here, it's not really going to appear among the first two non-zero terms, so we don't really care about it. So essentially, we can replace, in order to compute the first two non-zero terms, we can replace sine x with just x minus x cubed plus 6. All right, now how about 1 over 4 plus x squared? Well, to find it, so you need to we need to apply the geometric progression. So 1 over 1 minus x is 1 plus x squared plus x cubed plus and so on, right? Okay, so here we have 1 over 4 plus x squared, which is 1 over 4 times 1 over 1 plus x squared over 4, right? And plus x squared over 4 is really the same as basically 1 minus x squared over 4. Okay, so applying the geometric progression, we get 1/4 times 1. Now I'm going to replace x with minus x squared over 4, minus x squared over 4. Well, plus the square term, so which is x to the 4 over 16. Okay, so let me again use a different color. It's probably better to use a different color now. X 4 over 16 plus and so on. Right, my point being is that in order to find the first two non-zero terms, it is enough to just multiply these two with these two, because you know, the other terms are going to start with probably like x to the 5. There's going to be x to the 5 or x to the 4, right? And you know, x to the 5 or x to the 4 times x, which is again x to the 5, right? And you know, that then they're going to be probably the third or the fourth term and so on, right? And we just want to get the first two non-zero terms. So, which means that our function, which is sine x divided by 4 plus x squared, is really x minus x cubed over 6 times 1/4 of 1 minus x squared over 4 plus terms of higher order. Okay, and this is really what is 1/4. So we have x over 4, I guess, minus x times x squared is minus x cubed over 4, and there's going to be another x cubed over 4, so minus x cubed over 24. And again, so that there's going to be x cubed times x squared, so which is x to the 5, but this is already the next term, so we don't really need it. So we'll just write plus dot dot dot. All right, so that's basically it. So the first two non-zero terms are here. So I guess this is like x over 4 minus 1/4 plus 1 over 24 x cubed, and these are the first two non-zero terms for the Taylor series, and the answer is really from 0 to the integral from 0 to 0.2 x to the 4, basically minus, okay, I don't really want to do straightforward computation here, x cubed dx, so which is really x squared over 8 minus whatever 1/4 plus 1 over 24 and x to the 4 over 4, and then the change from 0 to 0.2, but that's already a straightforward computation, so that you can do yourselves.